Next point is SR clock flip-flop or clock SR flip-flop. This flip-flop has an extra input called clock. So this previous circuits and this circuits has only one difference is that it has one extra input clock. There is something modification in the previous circuits. Previous we have seen this only this circuits clock SR latch flip-flop. Okay, so in this circuit there is additional 2 NAND gates is included and clock input is applied. Therefore also called as gated or clock SR latch. Due to this extra input, this is called as clock SR latch. In this circuit's output is changed, that is the stored data is changed only when you give an active clock signal. So this circuit's output is changed only when you apply this clock input. तर या सर्किट मध्ये या सर्किटचा आउटपुट Q आणि Q बार मध्ये चेंज तुम्हाला केव्हा दिसेल जेव्हा तुम्ही क्लॉक हे इनपुट द्याल. ऑब्विसली तुम्हाला S आणि R ही पण द्यायचे, पण क्लॉक द्याल तेव्हा त्याच्यामध्ये तुम्हाला चेंज दिसेल. Obviously you need to apply S and R inputs, but you need to apply clock. After applying clock you see the changes in the output. We need to find out this truth table for 4 possibilities. This is circuit diagram. The output of SR clock is having 4 possibilities: 0 0, 0 1, 1 0 and 1 1. Step by step we find out the output for these 4 inputs. First is S equal to 0 and R equal to 0 inputs. When input S equal to 0, R equal to 0, see S equal to 0, R equal to 0. In NAND gate we have seen that if any one or both the inputs are 0, then output is 1. This is our observation in NAND gate. We have to apply this, we have to recap this. If both the inputs are 0, another input is 1, 0.1 is 0 and complement. NAND means there is a complement. 0.1 is 0 complement 1, and here 0.1 is 0 complement 1. Both are 1 1. We need to know what is the second input, because we have to know the second input, otherwise we can't predict what is the output. So in this case we can't find out the output easily. We need to assume what is the output previously. So in this case we have to assume some output that is stored previously. Consider if previous output Q equal to 0 and Q bar equal to 1. Q equal to 0 and Q bar equal to 1. This is our assumption. So assume output 0 coming here, second input of N2. Q bar equal to 1 that we assume is coming here. So N1 input is completed 1 1. 1 1 means 1.1 complement 1.11. 1.1 is 1 complement 0, and 0.1 is 0 complement 1. So we have find out the next state. This is PS means previous state, NS means next state. Previous state means previous output, previous data, and next means current data. Okay, so current value is 0 and 1. So if we look at the previous data and next data, both are same. That's why we can say there is a no change in the data, or the data is unchanged, or memory state, or no change state. We have to write this. Consider if previous output Q equal to 0, Q bar equal to 1, then both the input of NAND 1 is 1 high, so output of NAND 1 is 0, and one of the input of NAND 2 is 0, so we can easily predict output is 1. So final output Q equal to 0, Q bar equal to 1, which is similar to previous outputs. We have to write this in truth table. 0 and 0 inputs, clock is applied, output is previous state. Previous means just like previous outputs. That's why we can say Q and Q bar, no change state. Next we have to check the second conditions. s equal to 1 r equal to 0. S equal to 1 r equal to 0, clock is applied or given. S1 r0 clock given. So S n3 input is 1 and 1. 1.1 is 1 complement 0. N4 input is 0 and 1. 0.1 is 0 complement 1. So we can't predict the output of N2 because its one input is 1. But we easily predict output of N1 because one input is 0. So we can say easily output is 1. So one input is 0, output is 1. If we find out Q, then Q is coming here. The input of N2 is completed. Input of N2 is both are 1 1. 1.1 is 1 complement 0. So we have find out the upcoming or current output, that is 1 and 0. We have to write this. When input S equal to 1 R equal to 0, clock input is applied, output of N3 equal to 0, N4 equal to 1, then output Q equal to 1 because one of the input of N1 is 0 and Q bar equal to 0 because both the input of N2 is 1. This is set state. Set means output Q equal to 1. This state is called as set state because set is 1. या स्टेटला आपण सेट स्टेट का म्हणतोय कारण सेट हे इनपुट आपण 1 केल्यानंतर Q हे इनपुट पण Q हे जे आउटपुट आहे ते पण सेट झालंय 1 झालंय. ठीक आहे, त्यामुळे ह्या स्टेटला म्हणतोय आपण सेट स्टेट. We have to write this in truth table. S equal to 1, R equal to 0, clock is applied. Then Q is 1, Q bar is 0. This is set state. Next, third, when input S is equal to 0, R equal to 1. S is 0, R 1 and clock is given. So N3 input is 0 and 1. 0.1 is 0 complement 1 and 1.1 is 1 complement 0. So we can't find out the output of N1 because its one input is 1. We only predict output of N2 because its one input is 0. So one input is 0 means output is 1. 1 is coming here. Input of N1 is completed. Its input is both are 1 1. So output 1.1 is 1 complement 0. Now we have find out both the outputs. Output is 0 and 1. We have to write this. Output Q bar equal to 1 because one of the input is because one of the input of N2 is 0 and Q is 0 because both the inputs of N1 is 1. This is a reset state. Reset means output Q equal to 0. तर रिसेटला आपण 1 इनपुट दिलं रिसेट इनपुटला की आउटपुट तुमचं Q हे 0 झालंय, रिसेट झालंय, त्यामुळे याला स्टेटला म्हणतो आपण रिसेट स्टेट. We have to write this in truth table. When S equal to 0, R equal to 1, clock is applied, Q is 0, Q bar is 1. This is called as reset state. When input S equal to 1, R equal to 1, then clock is applied. Then both inputs are 1 1. 1.1 is 1 complement 0 and here 1.1 is 1 complement 0. So output of N3 is 0, output of N4 is 0. Both the inputs of N1 and N2 are 0 0. So its one input is 0, so we can easily say output is 1. Its one input is 0, we can say easily its output is 1. But both the output should not be same. So this is invalid state or we avoid this state. We have to write this. Output both Q and Q bar are 1, which is invalid state because they are supposed to be complement to each other. Normally this state must be avoided. तर यामध्ये आपण दोन्ही इनपुट 1 दिले की N3 आणि N4 चा आउटपुट 0 0 झालाय आणि 0 इनपुट असलं की आपण इझिली आउटपुट शोधू शकतो ते 1 येत आहे. ठीक आहे, आणि दोन्ही आउटपुट 1 आले तर दोन्ही 1 नको यायला, एक 1 आला की दुसरा त्याच्या अपोजिट पाहिजे. त्याच्यामुळे ही स्टेट इनव्हॅलिड स्टेट आहे आणि हिला आपण अवॉइड करतोय. वी हॅव टू राईट दिस इन ट्रूथ टेबल. S equal to 1, R equal to 1, clock is given, output is invalid. We can check this in simulator. If both the inputs are 0 0, both inputs are 0 0, clock is given, there is no change. If S is 1, clock is applied, S is 1, clock is applied, Q is 1, Q bar is 0. S is 1, yes, R is 0, clock is given, Q is 1, Q bar is 0. When R is 1, S is 0, clock is given, output is Q is 0, Q bar is 1. S is 0, R is 1, clock is applied, Q is 0, Q bar is 1. And if both the inputs are 1 1, clock is applied, then both output is 1 1, invalid state. Thank you.